Hi, I am Ik Cho from Seoul National University. Apologize for the synthetic voice, since I am recovering from COVID and could not organize the whole tutorial with my own voice. Today I am going to give a translation tutorial about building a dataset to measure toxicity and social bias within language, in a low-resource perspective. First, let me introduce myself briefly. I built several natural language datasets on the Korean language, and I am currently interested in dialogue analysis and AI for social good. In this tutorial, first I will briefly skim how hate speech is handled in real and cyberspaces. We take a look on how the issue was handled in English, where the progress in natural language processing has been leading a role, and how such findings were applied to other languages and made significant advances. Then we see the topic with low-resource perspective, where one may have to make datasets from scratch. This includes searching for existing language resources, defining the criteria for hate speech and offensive language within the language of interest, building up a solid data annotation guideline, and making up the corpus with sufficient agreement. We will conclude this tutorial with challenges of hate speech corpus construction and expected future progresses. Before we go to the main slides, we want to make a caution that this presentation may contain contents that can be offensive to certain group of people, though we are going to smooth it up for the presentation. Also, we want to state that in this tutorial, mainly handled are how to build up a hate speech detection dataset in a specific setting, and how to check the validity of the created hate speech corpus, but less handled are comprehensive definition of hate speech and social bias in the literature, and reliability of specific ethical guideline for hate speech corpus construction, because those topics are important but may not lead to a satisfactory answer with this short tutorial. We first see what hate speech is, and why it matters. It is difficult to define hate speech with a short paragraph, because it is a political and legal term than just a theoretical term, and has no unified or universal definition accepted to all since it highly regards one's acceptability to offensiveness or hostility. Also, its definition might differ upon contexts such as language, culture, domain, discipline, etc. However, here I bring a definition given by United Nations, in the sense that it incorporates almost all aspects that comprises hate speech. It is defined as any kind of communication in speech, writing, or behavior that attacks or uses pejorative or discriminatory language with reference to a person or a group on the basis of who they are, in other words, based on their religion, ethnicity, nationality, race, color, descent, gender, or other identity factor. It is said to be not a legal definition, and is broader than the notion of incitement to discrimination, hostility, or violence prohibited under international human rights law. However, this definition might cover the hate speech in cyberspaces which have been overlooked in the tight definition. Now let's look at the hate speech in cyberspaces. Though the definition was deductive, the detection is inevitably inductive, since real expressions, that is used in human language should be detected. They appear online as various expressions, such as offensive language, pejorative expressions, discriminative words, profanity terms, insulting, and so on. These specific categories are also rough term and are not fully guided with a clear boundary, and listing up examples of those expression might not be always helpful in extrapolating the neologisms and perturbated texts. Most of all, whether to include specific terms or expressions in the category of hate speech is a tricky issue. For instance, what if pejorative expression or profanity term does not target any group or individuals? Or, what if a harassment is considered offensive to readers but not for the target figure? These kinds of questions raise up issues that cannot be answered with a confidence. Thus, early studies on online hate speech detection, here we first talk about in English, discussed mainly on what attributes should be included in the category of hate speech and how they should be discerned from the text. Wasim and Hobie discussed the offensiveness of tweets, suggesting that about 10 attributes make a tweet offensive if such content is included. Though the attributes make up an offensive tweet rather than a hate speech, and the hate speech is included as an attribute here. This is regarded as a solid formulation on online hate speech given that most attributes mentions the reference towards minorities, which is a core factor of hate speech in our broad definition. However, this approach calls for the gray area, since the definition of minority might differ culture by culture, and it may overlook the offensiveness of counterspeech, which may also harm the readers in some regards. In this light, Davidson suggested that there should be gray area in the annotation process, mentioning the discrepancy between the theoretical definition and real-world expressions of hate speech. In this regard, offensive expressions were put in between hate and non-hate labels, which were decided based upon the voting of multiple annotators. It was shown that there were high frequency of offensive label tweets, and models seem to confuse between hate category and offensive category since large portion of offensive tweets incorporates profanity terms used prevalent in social media, which is offensive but does not necessarily target minority, avoiding the definition of hate speech adopted in the study. In other languages, in more detailed manner, Sanguinetti investigates hate speech for the posts on Italian immigrants with 6 factors that tells the property of the post. Beyond hate speech, annotators tagged if the post is offensive, aggressive, intensive, has irony and sarcasm, or shows stereotype. It is notable that stereotype is used as a factor that can be a clue to discrimination, since it is a factor that includes the existence of social bias in the tagging of hate speech. For Malta language, Asimikopoulos annotated Malta web texts and investigated the attitude of the text, asking for the target if the attitude is negative. Also, if there is the target group of negative sentiment, the way of representation is asked, which includes insult, sarcasm, stereotyping, threat, and so on. In this process, authors encouraged the workers to select all that applies, so that the problem does not turn to a simple multiclass issue. The further question asks if the post incites violence towards the target group. For the Korean language, which I participated in, Moon annotated Korean celebrity news comments with 2 criteria on social bias detection and toxicity measurement. Not only searching for the existence of social bias, it was investigated whether the gender-related bias is included in, reflecting the characteristics of celebrity news comments where discriminative expressions usually involve factors related to one's gender, especially on age or appearance. For toxicity measurement, the criteria of Davidson was adopted with a proper modification to the Korean language. To show how the hate speech corpus is constructed in a low-resource setting, I aim to demonstrate the construction process of this dataset in the rest part of this tutorial. Now we turn to the process of making up the hate speech detection corpus from scratch. We view this in a low-resource perspective, where there is no available resource to refer to in that language. For Korean, this was true until 2020, that is, there was no manually annotated hate speech corpus for the Korean language. However, I first want to point out that, generally, clear motivation is required for hate speech corpus construction. The reasons are, first, the construction process takes much resources, especially time and money, as creating datasets usually is. Second, creating hate speech corpus may cause mental harm to researchers and probably to crowd workers who are exposed to offensive and pejorative texts. Third, defining the scope of hate speech and offensive language directly reflects the philosophy of researchers, and this may call for some kind of attack towards the researchers if the work is disclosed. These are all obstacles of hate speech corpus construction and hate speech detection study. Nonetheless, the study is required in some circumstances. First, in view of service providing of text-based communities, detecting offensive language and automating the moderation is a crucial issue for maintaining the service. Also, regulation on pejorative comments in online spaces such as news comments is very timely process since severe harm is induced to public if such contents are disclosed without moderation. Although this always have a conflict with the freedom of speech, preventing possible harm seems to be more important issue in most communities nowadays. Now let's begin with analysis on existing language resources. Language resources on hate speech detection regards various other similar datasets, and these include Dictionary of Profanity Terms, Sarcasm Detection, Sentiment Analysis, and Offensive Language Detection dataset. For some languages, websites such as HateBase provide some widely used terms, but for Korean, profanity term dictionary constructed and maintained by enterprises was not shared public, so we could only rely on some bad word materials available online voluntarily constructed by some researchers and developers. Sarcasm and sentiment analysis dataset are not directly related with hate speech, but sarcastic and negative texts may comprise offensive language. Offensive language detection dataset usually covers broader area compared to hate speech dataset, and is very helpful for making up hate speech corpus if exists. Then we can ask why analysis on such existing resources is necessary. First of all, most importantly, it lessens the consumption of time and money that could be used in a duplicated work. Second, grounding on the previous work makes the problem easier, and sometimes provides supporting details. Also, by finding the difference with the previous work, we can confirm what we should aim by creating a new corpus. In case of Korean, we could find some available datasets online, for instance Dictionary of Profanity Terms, Sarcasm Detection Dataset, and Sentiment Analysis Dataset. Although they were not directly adopted for the construction, their construction schemes and contents can help set the direction of hate speech research, especially on definition, attributes, examples and so on. Here, in finding the source corpus to annotate on, one should think of its text style, text domain, and appearing types of toxicity and bias. First, text style of the corpus can indicate various concepts, but here we denote it as the text being written, spoken, or web text. Considering the characteristics of hate speech which usually contains offensive or hostile words that appears in conversation or chat, spoken language or web text corpora are more suitable for the source corpus. However, written corpora are also important since some texts display discriminative ideas only with descriptive and formal expressions. Next, text domain is the category where the text belongs to. For instance, news, Wikipedia, tweets, and so on. This categorization has overlap with text style, but more regards the topic or pattern of appearing lexicons, rather than the structuredness or grammaticality of the sentences. Next important feature is appearing types of toxicity and bias. It includes gender-related expressions, politics or religion, regional or ethnic contents, and so on. If one wants to focus on a specific topic, then it is necessary to first skim which kind of toxicity and bias appear in the corpus. The final feature is appearing amount of toxicity and bias, which is important to make up a class-balanced dataset. Unfortunately, this kind of balance is difficult to achieve before the annotation. Thus, one needs to conduct a considerate sampling process to guarantee that hate speech and non-hate expressions are sampled with balance. In case of Korean, comments were collected from the most popular Korean entertainment news platform, for the period of about 2 years. Among about 24,000 articles, 1,580 were acquired by stratified sampling, and among them, top 20 comments were extracted in the order of Wilson's score on the downvote for each article. Downvote-based sampling could make the distribution toward to the negative cases, but it did not necessarily harm the class balance since not all downvoted comments were offensive or pejorative. Further filtering was done to leave the comments of appropriate length. This kind of sampling process matters in the final distribution of the dataset. The next process is defining the categories that will be counted as hate speech. In this phase, local definition of hate speech was referred to, which is discussed by Korean Sociolinguistic Society. This may differ from the definition given by United Nations earlier, but for the Korean language, this is the most reliable reference since it bases upon Korean culture and language. Here, types of hate speech are listed in 4 types, namely discriminative bullying, discrimination, public insult and threatening, and inciting hatred. These factors are tailored to make up a more detailed guideline. Next step is setting up our criteria based on a reliable definition. We interpreted discriminate, hate, or incite discrimination, hatred, or violence, as a combination of social bias and toxicity of expressions. Besides, further discussion is done for the identification of social minority. All factors that comprises one's identity were considered, for instance, gender, age, professions, religion, and so on. Also, there is a discrepancy between the criteria for social minority and who will be acknowledged as social minority. These kind of factors are discussed by researchers to put in or remove specific factors of identity, and highly relates to the viewpoint of researchers on the scope of hate speech. For instance, on the factor gender, one may consider the hostility towards all genders equally in the sense that the scope of social minority differs by context and all the groups should not be the target of hostility, but others may think that social minority should be defined as the group with actual disadvantage in social or cultural context. With these in mind, criteria for bias detection was set up for the Korean language. We explained that bias is a thought that people with a specific characteristic may behave in some way, and emphasized this differs from a judgment that does not involve the identity of the target figure. Based on the involved type of identity, we count it if there is a gender-related bias such as gender, sexual orientation, sexual identity, and gender-related ideas. Examples for each factors are added to help how these kinds of discrimination are represented as a text. Next, criteria for toxicity measurement is set up in a similar way, including hate, insult, and offensive expressions. Hate and insult are usually counted as more toxic attribute compared to offensive expressions. In this step, profanity terms appear frequently in hate and insult category, but they did not necessarily lead the expression to be hate or insult, just remaining in the offensive category. Offensive expressions did not count as hostile or pejorative hate or insult, but included sarcasm, irony, bad guessing towards the celebrity, or unethical expressions towards the deceased, and so on. In this light, toxicity measurement was done in threefold, namely severe hate or insult, not hateful but offensive or sarcastic expressions, or none of the above. Different from the detection of social bias where the categories do not overlap with each other, measurement of toxicity is more close to the problem of continuum, and this threefold categorization could be elaborated to make up a range of scores on the intensity of expressions. However, to fit the task as a classification-based annotation, we remained this to a categorization task, where the workers would choose between 3 levels of degree. After setting up the concept of hate speech, the next is to build a guideline for data annotation. In this stage, mainly 3 stakeholders are involved in. The first is researchers who conceptualize the project and set the direction. The second is moderators, or the crowdsourcing platform, who receives the project and manages the overall worker flow. The last is crowd workers who are hired to the crowdsourcing platform or work as a part-time job, doing the annotation task based on the researchers' and moderators' instruction. Here, guideline is used differently by each stakeholder. For researchers, the guideline is used to represent their research direction. For moderators, it is used to understand the task and educate the workers. For workers, the guideline is a main reference for the annotation or other crowdsourcing tasks, from which they can discern what the researchers originally aimed at. However, such guideline is not built at once. First, a draft guideline is made up based on a source corpus by researchers. Then, researchers conduct a pilot study by themselves, sometimes multiple times of iteration to update and polish the guideline. If the semi-final version of the guideline is prepared, then the moderators and researchers try to make an alignment on the understanding of the guideline. This helps the moderator handle future communication and conflicts between researchers and workers. Then, crowdsourcing platform recruits workers and conducts a pilot tagging with them to select the workers and receive feedbacks. Researchers finally update the guideline with worker feedback to add cautions and exceptions that came out with the worker pilot. Then, the final guideline is eventually ready for the main annotation. Let me give a detail on each stage. First, the draft guideline is built based upon a small portion of source corpus, usually about hundreds of instances. Here, researchers' intuition is highly involved, and the descriptions are usually concept-based. For instance, for bias, we have described as, people with a specific characteristic may behave in some way. This gives a deductive concept on bias, instead of listing up all stereotyped expressions. The next stage is the pilot study of researchers, where they tag on slightly larger portion of source corpus, to fit their intuition on the proposed concepts. In this phase, discussion is much important since it relates to the questions and conflicts that may burst out during the actual worker annotation. But it is important not to fight here, since the difference of philosophy and spirit is inevitable in tasks like hate speech detection, since one's moral standard may differ from the other. It is important to find the area that at least researchers agree. Or find an oracle solution that all the researchers may agree without objection. After discussions, descriptions are updated or examples are added. Then, relabel, re-relabel, and label again to make up the final version. Pilot study includes an important step of calculating the agreement between the annotators, here the researchers. This is referred to as interannotator agreement or intercoder agreement, which represents the reliability of annotation or annotation scheme itself. Usually Cohen's kappa is used for 2 annotators and Fleisch kappa is used for more than 2 annotators. We don't handle the detailed calculation scheme here, but it would be safe to go annotation in the wild if the agreement between the researchers come out to be sufficiently high or satisfying. That is larger than about 0.6. Wrapping up these draft guideline and pilot study stage, it would be summarized as a circular diagram of guideline, annotation, evaluation, and revising, as depicted in the book of Pustajovsky and Stubbs. I believe the book will be a great help for all those who want to make or annotate their own natural language dataset. Next, we go to more a wild stage, and the first step will be finding a crowdsourcing platform to work with, or make a large-scale dataset with. Lastly, I mentioned the moderator as an equivalent to the crowdsourcing platform, but actually it is not necessarily equivalent since the platform may not have a moderator. Moderators are usually an expert in data creation and management, who comprehends the task, gives feedback in view of workers, helping communication between researchers and workers. They instruct workers and sometimes hurries them to meet the task timeline. Hopefully, they manage financial or legal issues, and let researchers concentrate on the task itself. What if there is no moderator in the platform and the platform only helps recruit the workers? Then, researchers should be the moderator, unless there are some automated functions that help researchers in the platform. But if there is the moderator, they will be the closest partner of researchers. In this sense, existence and experience of the moderator becomes an important condition for finding a collaborative sourcing platform. It is better if they have the experience of similar dataset construction, since it implies that they will comprehend better with the task and give proper feedbacks. Some moderators manage their own, trustworthy worker pool, thus how the workers in the pool are experienced would be another condition to consider. It is guaranteed if there is the trust between the moderator and workers. Of course, the moderator is not only reason for the selection of sourcing platform. Since dataset construction takes budget, it should also be investigated whether the price per tagging is appropriate or worker compensation is reasonable. If the price for tagging or reviewing is too high, it may exceed the budget or the resulting quantity of dataset might not be satisfying. If the worker compensation is too low, then it is expected to result in a low-quality output. Therefore, it is important to see if the cost estimation both satisfies the quality and the budget. In this phase, referring to multiple platforms and checking the ranking by each factor is important. Well, if budget allows, then the quality should be the first. Designing an appropriate reward system to accommodate enthusiastic participation of workers is also required. Another factor of good platform is the usefulness of the user interface. This factor may not be accessible before the start of the project, but in some cases, researchers can ask for the development of specific interface if the budget allows and there are a UI/UX team for the development of the interface. Some useful features displayed on the interface include progress status, worker and reviewer statistics, demographics and worker history, etc. These features are optional, but were quite useful in comprehending the overall progress. Next stage is crowdsourcing with hired or recruited workers. This also requires a pilot tagging process, which is in line with the pilot study of the researchers. Workers are given with the latest version of the guideline and tag a certain amount of samples, at the same time asking questions on misunderstandings. The primary goal of the worker pilot is updating the guideline in workers' viewpoint, especially on cautions and exceptions. Also, in this process, some workers may understand the aim and key points of the project quickly and yield a reliable annotation, while others may find it hard to follow up the project or stick to their own thoughts rather than the given guideline. The worker pilot is initiated by the advertisement of the project and the recruitment of workers. Then the worker tagging is conducted under the management of the moderator, and the researchers or moderators review the worker's output, giving accept or reject. For rejected output, workers revise the annotation and then resubmit to confirm the common ground. Researchers select the workers based on the result of the worker pilot. Then, which should we focus on? In hate speech detection, it is very important to fit the researcher's ethical standard with the workers. Thus, we thought it would be difficult to go along with the workers who have certain amount of annotations that differ with the reviewers, namely researchers, and the moderator. This kind of discrepancy appeared to be frequent among the social bias, since some workers confused correlated events with the causality, especially with ones containing gender-related stereotypes. In those cases, primarily reviewers gave reject. If the revised submission differs with the standard of the reviewers again, then the worker was not selected as a final participant. Some other automatic checkings were processed, such as checking the amount of work done or checking if there were too frequent cases of skipping the annotation. After the pilot and worker selection, main annotation is done with the selected workers. A simplified version of the guideline is usually given first in the crowd annotation, so that workers be familiar with the overall paradigm of the annotation. In this case, multi-class, multi-attribute tagging with 3 classes for bias and toxicity each. Given a comment without context, annotators are asked to tag each attribute. Annotators can refer to the detailed guideline which is separately provided, in the case they face confusing data points. Main annotation bases on the final version of the guideline, and 3 to 5 annotators tag one sample for usual classification tasks. Workers are selected by the previous pilot, or if such pilot is not affordable, researchers make up a short quiz that can test if the worker is equipped enough with the guideline. The annotation is done by assigning each sample randomly to workers, with multiple annotators per sample. If budget allows, the interface is developed or provided by the platform. However, if not, the annotation can be done using Excel or Google Spreadsheet, or open-source labeling toolkit such as Label Studio. If all the annotation is over, the data should be checked and the final label should be decided to guarantee the quality of the output. If sufficiently many annotators are available per sample, simple majority voting, or omitting the tag of the annotator with less frequency of being majority, would work. However, if not, and if automatic decision seems not reliable, researchers should check the labels again and make the final decision. In case of Korean hate speech corpus, the data left after main annotation reached 8,000. Though being the same 3-class annotation, the data reviewing strategy may differ by subtask. For both bias and toxicity, cases with all 3 annotators went through the researcher's adjudication and finally decided after the discussion. This is a usual process done in the majority voting of many classification tasks. However, for toxicity measurement, cases with only hate and none labels were investigated again, since such result is awkward considering that the problem regards the continuum of degree. The samples that failed to reach the decision were discarded. After the final decision, 3 sets were created, namely test, validation, and train. The split strategy can be done in many ways. In Korean hate speech corpus, authors chose to use more reliable dataset for test and validation. Test set consists of the data tagged while constructing the guideline, and they mostly adjust to the intention of the guideline. Validation set consists of the data which went through the review process in the worker pilot, which was done with a large number of annotators. They are deemed to be roughly aligned with the guideline since revision and resubmit of workers would have improved the reliability of the output. In contrast, for the train set, the data was constructed in the main annotation with the selected workers. Not all the samples were reviewed, but the dataset went through adjudication for some special cases. The final agreement turned out to be around 0.5, since the agreement was calculated with all the samples combined. Though this is the final stage of dataset construction, and a fair agreement was obtained, real usage of the dataset can further be checked with the implementation using machine learning models. The final stage beyond creation is model training and deployment. Though this stage is real important part in product service, we only look through some crucial parts in using the pre-trained language models in hate speech detection. Traditionally, models showing high performance meant the task being relatively easy, while low performance implied the task being relatively challenging. However, in these days pre-trained language model-based evaluation paradigm, there are some more points to consider in evaluating the dataset. First, pre-training corpora may play a significant role in the performance gap. In the table, a significant gap between CoBERT, CoElectra, KC-BERT and Songsil-BERT is shown, where the last 2 are pre-trained with online news comments, the most close to the source corpus used to make up Korean hate speech dataset. Not only the pre-training corpus, model size and model architecture also matter, here showing that larger models and Electra-based models perform better compared to smaller ones and BERT-based models. All these give intuition on which model should be used in the deployment, given that the performance of the total serving system is determined upon the performance of model detection and whether the size of the model fits with the capacity. Also, deployment would result in the user's feedbacks on the system, which may call for future update of the created corpus and the prediction model. So far we've dealt with the construction of hate speech detection corpus in the low resource setting. However, still many challenges are left in hate speech detection. First, the detection of hate speech is highly influenced by the context, such as articles, threads, and posts, but it is not clearly known that giving the context would always lead to more accurate answers. Also, the input format can be expanded to image or audio, as suggested in Hateful Memes Challenge, and the text input may have some perturbation as in LeetCodes or its Korean version, where the hate speech or offensive words are expressed in code-mixed manner, character jumbling, or optical tricks, to let the authority fail to detect the hate speech sent or typed online. Another challenge is that categorical or binary output may have limitation in that, categorizing the degree of intensity may lead to low agreement since it fits the continuous level of decision to a discrete level. Thus, Polito adopted scale-based annotation, namely unbalanced rating scale, and compared the result with the traditional categorical approach, using Italian tweets. It is expected that this can be used not only to determine the final label with more delegate granularity, also suggesting the way of formulating the hate speech task as a real number score-based regression. The problem of multiple label is also a challenging side of hate speech corpus construction. Aspect of discrimination may differ by attributes, and it is important to note that which kinds of discrimination appear in the sample. Thus, one can tag all the target attributes of discrimination that appear in the sample, which was done in Kong for the Korean language recently, with detailed guideline with terms and concepts defined for each attribute. This gives a multi-labeled corpus for hate speech samples, which can be used to make up a multi-attribute hate speech prediction that helps service providers analyze which kind of discrimination is visible in the user utterances. Next is the challenges of privacy and license, which has been much important recently in natural language dataset construction. They can be violated often with the text collection using crawling. Hate speech corpus may contain personal information on public figures, and some texts there could have been brought from elsewhere with tight licenses by users, with a simple copy and paste. In this light, Yang proposed generating the text from scratch, by recruiting workers and a moderator to enable anonymous text generation. By guaranteeing the anonymity, the participants can generate hate speech and confusing non-hate speech with less embarrassment, also being paid by the moderator to get an appropriate compensation for their creation. The left ones are more challenging factors that may has not been sufficiently tackled yet. First, since text incorporates various ways of interpretation, the ambiguity is inevitable for some hate speech. If omission or replacement is accompanied to trick the monitoring system, and the intention is apparent considering the context, there is no clear solution to judge them as a hate speech with just suspicious expressions. Next, temporal diachronicity of the text is a core difficulty of detecting hate speech since it evolves day by day. Along with various neologisms and acronyms. Non-hate speech in the past can be interpreted as hate speech these days, and this diachronicity may deter the utility of ready-made prediction systems, which necessitates online or continual learning of the models. For instance, in the case a celebrity committed crime, the name of the celebrity becomes a kind of taboo or profanity term from the period of social disgrace. Finally, the most important issue as always is that the boundary between hate speech and freedom of speech is very gray. For any kind of hate speech detection system, some readers may be offended by false positives and some users may be offended by false negatives. It is an important role of service providers to fit the need of both sides, minimizing the mental damage of people who are exposed to the hateful words. This is our short conclusion. Hate speech is prevalent in real and cyber spaces, and its discussion was done in diverse viewpoints, which were reflected to the overall dataset construction processes. However, no corpus is built perfect from the beginning, and hate speech corpus is one of the most difficult kind of dataset to create. We skimmed through considerations in the hate speech corpus construction in low resource setting, especially on the reason we created, the strategy, the quantity, and the quality. Though still more challenges are left on context, noise, output format and the chronic indecisiveness, I want to give 2 takeaways from this tutorial. First, we should be aware that there is discrepancy between theoretical and practical definition of hate speech, and their aim may differ, so we should understand it in the dataset construction process. Also, there is no guideline that satisfies all, so we should first find the boundary that satisfies the most and make an improvement from there. This is a full reference list of this tutorial. Thanks so much for listening.